So after installing the MLG setup software on your PC, launch the program. You can choose your language, and it will start up with a configuration setting here, and we will just say, yep, we want to parameterize the MLG. We don't have a file to install. I'm going to download data from the MLG. This works if you have MLGs installed, the Lightgrids installed and hooked up. If not, this is where you choose the size and the beam spacing you want, as well as the type of output you want, whether it's PNP, NPN, RS-485. Here, like I said, I have one installed. I'm going to hit finish at this point, and it brings up a screen. This is the MLG. So this is the one that was chosen either for simulation or I actually have hooked up. So this software works well with sensors. It also works very well when just being used as a simulation. So to simulate what's going on here, we can grab the simulated object with our mouse and bring it in, and we can see green are beams that are not blocked and red ones are blocked. And I can change the size of the simulated object here with the mouse, or over on the right and the bottom, changing the width and the height and the location through the beams. And as you move through, you can see the numbers change over on the right. So this is the important part. This is the data that's coming back, and all the decisions are made based on this information. So number of beams blocked is 4. The first beam blocked is number 7. The last beam is 10. So basically, as I move this around, I can see, right now I'm going to get, in between a couple beams where the number of beams blocked is only going to be 3 as it moves through. If I make it larger, the numbers change. And with that information, then we actually get into the setup of what do we want to do now that we have how many beams are blocked, how many are made, and where they are. Now we can change the outputs. The device I have hooked up has 3 discrete outputs, and they can be set up. I'm just going to clear these out. Right now, a standard one is number of beams blocked is greater than or equal to 1. Then you get an output. You can invert any of the outputs, meaning that it's kind of normally open, normally closed. I can have the second output be if the number of beams blocked is less than or equal to, I'm going to type in 10. I can have a third output say, but I also like to know if the first beam blocked is greater than or equal to 10. Oops, 10 again, just as a good number. And the number of beams blocked should be less than 5, whatever numbers we want to choose. And so know that those formulas go in here. So right now, is the number of beams blocked less than 10? Yes, it is at 0. So that output is active. As soon as I bring in my simulated object, we'll see that the number of beams blocked equals to 1, and it's less than 10. That's all true. So both of those outputs are on. Once I block more than 10 beams, now that second output goes on, and you can see basically what happens. And you can, with the Boolean logic of these, you can get some very interesting results. So if the first beam blocked is greater than 10, so I need to get this, now it's 11, and the number of beams is less than 5, then we're in good shape. So right now I'm blocking more than 5, so as soon as I bring the number of beams blocked, now that output is on. One output option we have is to have an analog output, actually 2 analog outputs. So to see that, I went to File, New, and I'm going to go through here. I'm going to pick one now that has an analog output, or in fact, in this case, 2 analog outputs. I'll scroll up and find one with 4 PNP outputs and 2 analog outputs as well. I'm just going to go ahead and hit Finish like we did before. And what we'll see here is at the bottom is we have a status of analog outputs. And as I move my simulated object through, or if you went in online mode, you'll see what kind of function you chose and the analog output that you would get. And you make these settings again by going up to the parameterization or the setup window. Now if you chose one that has an analog output, you have a tab that says analog output. You click that and you say, well, let's say I want to do positioning, so I want to know where it is. So I want to look at the first beam blocked, and I'll do that. I want a 0 to 10 volt output from beam 1 being basically be 1 volt, and if you had 10 beams, the 10th beam would be the 10th volt, or 10 volts. So, and also I want to know the size. So I want to know the number of beams blocked. So I want to know the position and the size. And I'll do that, let's say, in a 0 to 10 volts as well. Click OK, and so now basically as I move my object in like I usually do, I get my PNP outputs as I configured those, and now I get an analog output as well. So basically I have, let's see, I'll put it in here, number of beams blocked I'm blocking 7. So basically the whole way through, well, 6 in between beams, I'll get a 2.3 volt or a 2 volt output. If I size this a little differently, I'll make sure I pick up all the beams. So I'll always get the same number of beams blocked if I pick up all the same beams as I go through. But you can see the first beam blocked. As that changes, so does the analog output. And we can choose that to be in voltage or current and inverted or not. So it's scalable in a way that the first beam blocked or whatever it is always the lowest voltage or current, and then it's the highest voltage or current. And then you can invert that. If you want to do any other scaling, basically you have to mute or blank out beams if you don't want those to be included into the analog output. If you have MLG hooked up, like on our demo case, you can actually go online with the part. And now I can put my hand in here and move my hand up and down, and you can see in real time what's happening. I'll spread my fingers apart here, and there's my fingers, 4 fingers in blocking the beams as they go through. And if I just take one finger and move through, you can see sometimes I block 1, sometimes I block 2, depending on the size of the object, and the beam spacing is going to be whether you're able to actually detect a product or not. One things we can do here is to set up this multi-scan, and that'll help us to detect smaller objects. One of the other things you do too here is if you have sensors set up, hit the automatic sensitivity adjustment at the range that you have your sender and receiver. So you should actually do that right away when you set up the sensors, and that sets all the thresholds. But in here also you have the 3x multi-scan. So I'm going to turn that on. And now instead of parallel beams, instead of beam 20 being received by receiver 20, now we actually have sender 20 sending out and picked up by 19, 20, and 21. So we're able in this case to actually see smaller objects because now we're blocking more beams. So I can make some very small objects here that normally would not be picked up. So minimal detectable object, MDO, is 10 millimeters on this crossbeam. So now I can actually pick up some very small objects that I wouldn't be able to if I didn't have the crossbeam on. Now, one of the warnings there that came up when I turned this on was that for the actual measurement items here of which beams are blocked, it's only going to use the parallel beam calculation. So sender 7 and receiver 7, but it'll be able to detect much smaller objects. So if I go in and turn the multi-scan off, you'll see such a small object like that, could easily pass through the 10 millimeter beam spacing and not get picked up. The software is loaded with lots of features and things that can be used in your application. So spend some time just looking around, in some of these different window modes. One of them is different inputs that we can do, and you can have it do no function at all. So there's actual discrete input pin, and if it goes high, then you can have it do different things like enable the output. So if you don't want anything to happen unless you tell it, you can do that. Also, blocked beam hold is a good function to take a look at. And what this does is it holds, or does like a peak hold, on the blocked beams. So if you're looking across a conveyor and a pallet moves through, first the pallet's going to block a couple beams, then you're going to have a load come in, it's going to block a bunch of beams, and then move through, and then you'll just have the pallet and it'll be gone. And all that information you would have to have collected in real time as you went by. Or you can give that digital input. Here I'm going to simulate that by clicking a button and turn the blocked beams hold on. So now the pallet will come in, and then the load will come through, and then the load gets a little bit smaller, and then the load gets bigger as it moves through, and then back out, and then there's just the end of the pallet, and then it's gone. And here it's held that data, so now you can go back and query and say, oh, how many beams were broken? Oh, 13, and where was it? What was the first beam and the last beam blocked? And it'll hold that information for gathering later. It's also very good when using a 485 output. So here we have just 3 switching outputs, but you can also get these devices with serial output that outputs all the beam status and all this information serially, and you might be getting way too much information. You really just want to know what the size of something was that passed through. So what I've done now to show that is I've actually said, this is a different light grid than what I have hooked up. I actually have one with 4 discrete outputs and RS-485. So I'm doing a simulation of an MLG here. And as I bring this through, we can see not only all this data of how many beams were blocked, but we can see that translated into what we're going to send over the RS-485. Right now it doesn't make a whole lot of sense because it's in hexadecimal. So we're going to go into the same parameter window. We're going to now look at data interface. That wasn't there on the earlier one. And here we can pick up all the standard communication information. Instead of hexadecimal, let's just do decimal so we can read it. We'll pick a slash. And you can tell I'm going to have a continuous output. I can just say it's on demand. When I send it a character, I can have it at certain intervals, or I can just say, give me an output if the beam status changes. And that's very useful. And here I'm just going to get what the beam status is, separate with a slash, and then I want to know actually what the number beam blocked was, and I want to know what the first beam blocked is. So now as I move my object through, right now it's going to say, well, it's going to give me the status of the beams. It's going to tell me that the number of beams blocked is 6. It's going to tell me the first beam blocked is 2. And this, with the blocked beams hold, is very good for measuring things as they pass through the light. Another good use of the software is to look at the timing of the sensors in your application. So again, let's say this is across a conveyor and there's boxes moving through. It'll tell you what the minimum presence time needs to be. How long does the object need to be in between the beams, the response time of it. And then there's a nice wizard here. If you know the object length, you click this. Or if you know the velocity of your conveyor, you click this. So basically, if you know, my conveyor is moving at 10 meters per second, you give it that information, and it'll tell you that the object length can be, 41 millimeters. Anything shorter than that, and you may miss it. And then vice versa, if you know the length, you know that your shortest box, is only 10 millimeters, then it'll tell you that you can't move then faster than 1.4 meters per second. Otherwise, you might miss it as well. So after making any configuration changes, using the multi-scan, changing what your outputs are, or your 485 output data is, you do need to upload this to these sensors. So you actually have to click this, the button that says, from the parameterization up to the light grid, and you do that uploading, and it will get all that information in. Then you can save it as well. So I just downloaded the information from the light grids. Now I'm going to send it back up, any changes that are made, and then you can save these files as well, so that you can open it up later, connect a different light grid, and just load all that information back into either a replacement, or if you're doing multiple light grids with the same setup, you can move that configuration in. There's a lot of very good applications and wizards in here to help set up for particular applications. You can mask off beams that might be blocked by the conveyor or rails. You can set up different kind of inputs. Certainly do lots of different things with the output. Change alarm settings on here for contamination. So there's a lot of different things you can do. Hopefully this tutorial went through enough of the program to get familiar with looking through there and seeing what features that might benefit you in your application. If you do have further questions, please contact your SICK sales representative, the SICK application engineering, or product management. Thank you very much for your interest in the MLG and the MLG setup software.